Welcome to the AI Checkpoints. Today, we're diving deep into a term that's, well, it's becoming absolutely foundational if you're building anything with AI. Context engineering for AI agents. If you've ever tried to build an AI agent and, hit that frustrating wall where it doesn't quite work right. Maybe it's hovering around 70, 80% quality. You know how maddening it can be to get past that barrier? Developers often find themselves like 7 layers deep in a call stack trying to debug how a prompt was built or where a tool even came from. Sometimes you just feel like throwing the whole thing out and starting again. Dex Horthy from Human Layer talks about this exact thing in his 12-factor agents talk. It really captures that feeling.
Precisely. Yeah, it's a common pain point. And our mission in this deep dive isn't just to define context engineering, but to really unpack why it's becoming, well, probably the most vital skill for anyone building these agents. We'll explore the practical strategies, the nuts and bolts for creating agents that are actually robust and reliable. And we'll be drawing on some great insights from people really pushing the field forward. We're talking Dex Horthy's 12-factor agents, Cole Medine's context engineering blueprint, and some great discussions from LangChain and Automatic Learning Lab, too. So yeah, let's get into how we solve that tricky last 20% problem.
Okay, so to kick us off then, what exactly is context engineering? It sounds a bit like sci-fi, but clearly it's very practical.
It does sound a bit grand, doesn't it? But it's actually quite elegant once you get the core idea. Think of it like this, and you hear similar analogies from folks like Toby at Shopify, Carpathy, and it's echoed by LangChain at Automatic Learning Lab as well. An LLM, a large language model, it's like your CPU, a powerful processor, and its context window. That's its working memory, its RAM. And just like your computer's RAM is limited, the LLM's context window is too. So context engineering is basically the art and science of filling that limited window with just the right information at each step the agent takes. It's all about carefully curating what the LLM sees and remembers moment to moment.
That's a great analogy. RAM for the AI. That clicks. But why is it suddenly such a hot topic now? What's changed?
Well, the whole game has changed, really. LLM applications aren't just about single questions and answers anymore. We've moved into building these complex, dynamic, agentic systems, as Automatic Learning Lab calls them. Systems that take multiple steps, use tools, interact. And the core problem, the bottleneck, is that LLMs are fundamentally just text in, text out machines. If a task needs knowledge or steps beyond what the LLM was trained on, well, it often gives you a pretty useless response or just makes something up, like ask an LLM about a brand new tech protocol, maybe the model context protocol, without letting it search the web. It just won't know. It can't.
Right. So it's not just asking the right question anymore. It's like you have to provide all the necessary ingredients for the LLM to actually cook the meal.
Yeah. Exactly that. Yeah, Automated Learning Lab really emphasizes this point. A good output isn't just about the task or how smart the LLM is. It's just as dependent on the quality and the relevance of the context you feed it. In fact, you hear lots of experts now saying context engineering is basically the #1 job for engineers trying to build truly effective AI agents. It's that fundamental. If you think back maybe a year or two ago, all the buzz was around prompt engineering, right? Crafting those perfect magic words to coax better answers. It felt a bit like alchemy sometimes. But now, as Automated Learning Lab points out, the focus has really shifted dramatically. Now it's all about providing good context. Prompt engineering is still important, sure, but it's really becoming just a subset of this bigger thing, context engineering. It's less about the magic spell, more about setting the stage perfectly.
Okay. Context is king. Got it. But you mentioned dynamic context earlier. That sounds tricky. How does context change within an agent, and why is that hard to manage?
Yeah, dynamic is where it gets, well, wild. In an agent loop, the LLM might decide, okay, I need to use a tool, maybe a calculator, maybe search. He gets a result back in observation and then decides the next step. But calling those tools, it's often probabilistic, not guaranteed. So the context isn't static, it's constantly changing. The agent might need to call a specific tool right then there to get new data, process it, fold it into its understanding, and that's where simple static prompts really start to fall apart.
So if the context is constantly shifting, does the prompt itself need to shift too? Or at least somehow influence how the agent deals with that shifting context?
Absolutely, that's a really critical point. The prompt has to influence the likelihood of the LLM calling the right tools when needed. Automatic Learning Lab had this great example. They asked ChatGPT about that model context protocol. When they told it not to search the web, it just confidently made up an incorrect answer. Classic hallucination. But when they prompted it to search the web, bang! It used the right tool, found the info, gave the correct up-to-date answer. It's a perfect garbage in, garbage out scenario, right? The prompt's ability to guide tool use directly impacts the result. It's about enabling the LLM to find what it needs.
Okay, this is getting really interesting because it's not just about external tools like search, is it? It's also about how we structure the task itself for the LLM. Like I've seen examples where asking for an essay gives you much, but breaking it down helps massively.
Spot on. Yet think about asking an LLM to write an essay on, say, Montaigne. Just a vague prompt, you'll probably get a pretty bland, generic summary. High school level stuff. But, as an Amado Learning Lab showed, if you first ask the LLM to create a structured outline, and then you feed that outline back into the prompt for writing the essay, the quality, the depth, the organization, it just goes way up. It really highlights that setting the LLM up for success, making sure it has the right info, the right tools, or even just the right internal plan to follow, that's the key. You got to provide the scaffolding.
Okay, right. So if context is this vital dynamic thing, what are the actual strategies? How do we do context engineering well? Where do we start building that scaffolding?
Yeah, good question. LangChain actually put out a really helpful video, Context Engineering for Agents. And they break it down into 4 main categories. It's a really useful framework they talk about. Writing context, selecting context, compressing context, and isolating context. These are like your 4 pillars.
All right, pillars. Let's unpack those. First one, writing context. Is this like the agent taking notes for itself, like an internal scratchpad?
Exactly. That's a great way to put it. Just like we humans jot things down or try to remember stuff for later. This bucket includes a couple of key ideas. First, you've got scratchpads. These are for holding information within a single agent run, a single session, temporary memory for the job at hand. Anthropic's multi-agent researcher, for instance, might save its plan to this kind of memory. So even if the main context window gets full, it can still refer back to the plan. Doesn't matter how it saves it, file, database, whatever the point is, writing stuff down during the task. Then, maybe more powerfully, you have memories. These are about holding on to information across different sessions. Long-term recall. Think about ChatGPT's memory feature or tools like Cursor and Windsurf that automatically build up a memory from your past interactions. These aren't just static notes either. They often update dynamically. So the agent starts to feel smarter over time, remembering things you told it days ago.
That makes a ton of sense. Short-term notes, long-term memory. So once we've written all this info down, how does the agent pick out what's actually relevant now? That sounds like selecting context. Must be crucial with loads of info.
Crucial is right. This is where things get really sophisticated, and it makes a huge difference in performance. It's not just about grabbing the latest note from the scratchpad. For big knowledge bases, you use advanced retrieval techniques, things like embedding-based similarity search, which basically means finding info that's conceptually similar to the current task, not just matching keywords. Much smarter. Or you might use graph databases, which are brilliant for mapping out and querying complex relationships between different pieces of information. And here's a really big one for agents, especially ones with lots of tools. Retrieval Augmented Generation, or ARA, but applied to the tool descriptions. LangChain found that agent performance can really tank once you give it more than, say, 30 tools. And they often just break around 100 tools. Why? The context window just gets totally clogged with descriptions of tools it doesn't even need right now. So RROC for tools means dynamically fetching only the descriptions of the tools relevant for the current step. Huge performance boost. And this whole RRAG idea applies to general knowledge too.
Good RAG systems, mixed techniques, semantic chunking, file search, knowledge graphs, maybe even using another LLM to rank the results to make sure the absolute best, most relevant info gets pulled into the context window right when needed. Stops the LLM getting lost in noise.
Okay, RA for tools. That's clever. Then the third pillar was compressing context. My instinct says this is about being efficient, squeezing the most value out of that limited RAM, that context window. Less is more.
Absolutely. Every token costs, right? Both in terms of performance and often actual money. So you need to be smart about what stays in context. The main technique here is summarization. For example, some models like Claude Code, when they sense the context window is getting nearly full, like 95%, they'll automatically summarize earlier parts of the conversation to free up space, keeping the gist but ditching the fluff. You can also do this more deliberately, like summarizing complex data before handing a task off from one specialized agent to another. You see this in multi-agent setups. Pass the insight, not the raw dump. Another technique is trimming, basically selectively chopping out less relevant bits. Could be simple, like just keeping the last 10 messages. Or could be smarter, using heuristics or even learned models to identify and remove the noise.
Right, trim the fat. Okay, final pillar. Isolating context. This sounds like maybe creating separate little work areas, preventing the LLM from getting overwhelmed by seeing everything at once.
That's exactly it. Creating focus. The most obvious example is multi-agent systems. Frameworks like OpenAI Swarm or Anthropic setups let you have multiple sub-agents working in parallel. Each gets its own smaller, focused context window. This massively increases the total amount of information the whole system can handle. You can generate really rich outputs this way. Dex Horthy's idea of microagents fits here. Too small. Specialized agent loops doing one specific task within a bigger workflow, like having a team of specialists. You can also use sandboxing, like if you need to run code or deal with big files like image or audio. Do that outside the LLM's main context. Just pass back the important result, the code output, a description of the image, not the whole heavy thing. Hugging Face does research on this. The LLM doesn't need the whole picture, just the summary. And finally, using a runtime state object. Think of it as a well-defined data structure, maybe like a pedantic model in Python. It lets you organize context in a different field and only show the LLM the specific field it needs for the current step. Keeps things tidy and focused. Prevents information overload.
Wow, okay. Writing, selecting, compressing, isolating. That's a really solid framework. So we have these tools, but how do developers actually put this into practice? What does building a good, reliable agent, one that gets past that 80% hump, look like day to day?
Yeah, it really boils down to treating agents like proper software, not just magic prompt experiments. Dex Horthy's 12 Factors of AI Agents hammers this home. It's basically software engineering 101 applied to agents. He argues you absolutely have to own your prompts and fundamentally own how you build your context window. Every single token matters. So it's about optimizing for density, for clarity. Sometimes, yeah, it means handwriting specific tokens or instructions to guarantee quality for critical steps. It's about being intentional.
So for example, if an agent hits an error, like an API call fails, you shouldn't just dump that whole messy error message back into the context window, because that would just confuse it.
Exactly. That's a super common mistake. You see raw stack traces flooding the context. No, you need to summarize the error. Tell the LLM concisely what went wrong and maybe what it should try next. Dex Horthy stresses this. Give it useful info for a retry, not noise. And this applies to humans too. Agents often work best when they can loop in a person smartly. So designing them to contact humans with tools, where the agent signals its intent clearly, like, I need manager approval for this, allows for what Dex calls auto-outloop agents. They know when to ask for help gracefully. And another key point he makes, users don't want a dozen different agent apps open. Agents need to meet users where they are. Integrate into Slack, email, Discord, whatever. Make it seamless. Ultimately, agents are software. They should be stateless, with their state managed externally, maybe in a database. Makes them flexible, allows pausing, resuming, saves so many headaches later on.
Treat them like real software. That makes so much sense. Okay, and speaking of building, what about using AI to help build these agents? That sounds a bit meta, using AI to make AI.
It is meta. And that's where Cole Medden's work, particularly his context engineering blueprint and the PRP framework product requirements prompt, comes in. He points out a problem many of us have probably experienced. AI coding assistants can often just vibe code. They give you these cool-looking demos that then just completely fall apart when you use real data. They get stuck in these endless debugging loops. Why? Because they don't have enough structured context to build something robust.
Right, the vibe code prompt. I've seen that. So how does this PRP framework fix it? How does it add that needed structure?
It forces a really crucial planning phase before code generation. You start by describing your agent. Then the AI assistant helps expand that into a super detailed product requirements prompt, the PRP. This thing is like a blueprint. It includes everything: documentation links, API specs, required code structure, libraries to use, even common pitfalls or best practices for that specific kind of agent. Providing all that upfront drastically cuts down on the AI making stuff up or going off track. But here's the absolutely critical part. You cannot just trust the AI-generated PRP. You must validate it. Cole Medden really emphasizes using validation chains. Write unit tests for the PRP itself. Check the AI's confidence score. Refine that blueprint before you hit go and have the AI build the agent. Spend time on the plan, not just the code.
Wow, okay. So what started out sounding kind of abstract, context engineering, really turns out to be the absolute bedrock. It's the foundation for building AI agents that actually work reliably. It's not just about the prompt anymore. It's this whole meticulous, dynamic process of managing all the information the LLM needs, moment by moment, to function like resilient software. That's a huge shift.
It really is. It's the skill set that lets you push past that 70–80% quality ceiling and turn those often frustrating LLM outputs into genuinely effective, targeted solutions. This is definitely an emerging, super important skill. Requires a deep understanding of how these models process information and, crucially, how you can precisely guide that process.
So here's a final thought, maybe something for you, the listener, to mull over. As these LLMs keep getting smarter and context windows keep getting bigger, exponentially bigger, It feels like sometimes, do you think context engineering will still be the #1 job? Or will the LLMs eventually just figure this out themselves? Will they manage their own context perfectly?
It's a great question. But I think, regardless of how smart they get, understanding these underlying principles, how to structure information, how to retrieve relevant data, how to manage state, that understanding will always give you an edge. It'll help you debug when things go wrong, design better systems, and find those truly cutting-edge solutions. The fundamentals of information flow probably won't just disappear.
Absolutely. Well, this has been fascinating. Thank you for joining us on this deep dive into context engineering for AI agents. See you next time.